everyone, today we're going to do something that honestly looks like a real magic trick. We're going to take some super ordinary stuff and, well, with just a little bit of patience, we'll see an incredible transformation. So let's just dive right into this awesome experiment. So here's the big question, the mystery we're trying to solve. Can a totally normal, boring iron nail actually change the color of a solution and coat itself in a brand new metal all at the same time? I know, it sounds like something straight out of an alchemy story, right? But believe me, what we're about to see is 100% real science. All right, every good magic trick needs a setup, right? So let's look at our props. And I promise there's no smoke and mirrors here, just some straightforward chemistry. So our cast of characters is pretty small and simple. First up, 3 clean iron nails. Seriously, nothing special about them. Then 2 regular old test tubes. And for our stage, this really vibrant blue copper sulfate solution. Now you're going to want to remember this color because it is super important for what comes next. And the procedure? Just as easy. Okay, so first, we're pouring that blue solution into both test tubes. We'll call them A and B. Next, we'll carefully drop 2 of the iron nails into test tube B. Now test tube A and that last nail, we're just going to set them aside. That's our control, and it's really important because it gives us something to compare against, so we can see just how big the change really is. Okay, and now for the hard part. We wait. We need to give it about 20 minutes. We're just going to let chemistry do its thing. This is where the real magic happens. 20 minutes, it's not a super long time, but it's more than enough for a quiet but really powerful chemical reaction to kick off inside that test tube. Right now, as we speak, the atoms of iron and copper are doing this little dance, this invisible swap where they totally rearrange themselves. All right, time's up. The wait is over. It is time for the big reveal. Let's go see if our little magic trick paid off. Whoa, look at that. Seriously, check it out. Over here on the left, we have our control, test tube A, and it's exactly the same deep, vibrant blue we started with. But look at test tube B. It's a totally different color now. The blue's almost gone, and it's been replaced by this pale, kind of light green color. That is a huge change. Okay, so let's just quickly recap what we've just seen. First, the most obvious thing, the color of the liquid completely changed. But the second thing, and this is just as cool, look at the nails. The ones we just pulled out of test tube B, they aren't gray and shiny anymore. They're covered in this weird reddish-brown coating. I mean, that's 2 amazing transformations happening at once. Okay, so obviously this isn't actually magic, right? It's chemistry. So now it's time to pull back the curtain and really understand the science behind what we just saw. Let's decode this reaction. And this right here, this is basically the secret spell. This chemical equation tells the entire story. You've got iron, that's Fe, reacting with copper sulfate, that's CuSO₄, and what does it make? Well, it makes iron sulfate, FeSO₄, and pure copper, Cu. Literally, every single thing we just observed is explained perfectly by this one little formula. So, the fancy scientific name for our magic trick is a displacement reaction. And honestly, the best way to think about it is like a stronger athlete on a team tagging in and kicking a weaker player off the field. One element literally just pushes the other one out of the way and takes its place. But that leads to the next big question, right? Why? Why does the iron get to kick the copper out and not the other way around? Well, the answer comes down to a really fundamental rule in chemistry. It's actually this simple. Iron is more reactive than copper. That's it. It just has a stronger chemical desire, you could say, to be part of that compound, to be bonded with the sulfate. So this isn't some random thing happening. It's totally predictable, all based on the basic properties of these 2 metals. So let's zoom in and see what's happening on the atomic level. Because iron is more eager to react, the iron atoms literally jump off the nail and into the solution. When they do that, they give up some electrons. That's a process called oxidation. So where do those electrons go? Well, they're immediately grabbed by the copper ions that were floating around in the blue solution. That process is called reduction. And once the copper ions grab those electrons, they turn back into solid copper atoms, and that's the reddish-brown stuff that coats the nail. So what's left floating in the water? Iron sulfate. And guess what color that is? Yep, pale green. See? Every single thing we saw is explained by this awesome chemical swap. This one simple experiment really pulls back the curtain on a hidden world of chemical competition. It really makes you wonder, doesn't it? What other invisible chemical battles, these little displacement reactions, are happening all around us all the time? I mean, in everything from the batteries in your phone to the way a car rusts. It's just a fantastic reminder that the world around us is so much more dynamic and alive than we even realize.